Oh, we got all our guests are piling
Welcome
up at
to
one time. This isn't
Spaceflight
good.
Insider Live.
Good morning, folks. This is Jason Rhian with Spaceflight Insider SFI Live, and we are in Promontory, Utah for the test of QM1. That's Qualification Motor 1 that Orbital ATK and NASA are carrying out to have these solid rocket, 5-segment solid rocket boosters power the Space Launch System to destinations such as an asteroid and in the 20 Mars. Now, we have had phenomenal treatment in the past 3 days that we've been here. We've run all across the high desert out here in the salt flats. It is just, it's amazing because the first 2 days we were here, it was nothing but blue skies. And now we have this, no, it's overcast. Like, no, 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 no. The rocket's not going up. It's staying horizontal. And more importantly, that creates a little acoustic thing. So if you look right behind us, you can actually see the structure. I'm pointing like blindly. And you're going to see the test actually take place right behind myself and the guests that we have at that time. Now, speaking of guests, I am very fortunate to be joined by Orbital ATK's safety. She worked for Safety and Mission Assurance.
That's right.
And that is Sarah Hiza.
That's correct.
Sarah, welcome to SFI Live.
Thank you so much. Good morning.
Good morning. It is a good morning.
It is.
It's a
exciting.
little cold out here, though, ain't it?
I'm feeling pretty good.
I need some hot cocoa.
We've had a mild winter this year.
You call this a mild winter? I'm
I
from
do.
Florida.
Okay.
This isn't mild. This is. I'm weak, but so. Your job at ATK or Orbital ATK, we're still, some of us in the business are still getting used to that transition.
Sure.
What is it like? What do you do?
So Safety and Mission Assurance is a behind-the-scenes kind of team, and that's why I'm excited you gave me the opportunity to talk about them. My team, first and foremost, with a rocket like this or any of our products, spend a lot of time ensuring that our processes are safe for both the people as well as for the product and the facilities. So we do a lot of analysis on, like, even not necessarily just the propellant piece, which may come to mind, the hazard
Right.
propellants and ordnance and such things like that. But we spend a lot of time also on the large equipment, so moving the cases and the motors themselves. It's large equipment, and we do a lot of margins analysis. How margin analysis meaning safety margin as far as our window from where we would have an issue, a safety issue.
Would it be fair to relay that to our viewers as like your comfort zone?
Yeah, exactly.
That's a good way to look at it.
That's right. And
Okay.
we do that quantitatively as well. So we do some process analysis, but then we do true quantitative physics-based analysis as well. Our hazards analysts are experts in that. And so that's a big piece of what we do, ensuring the safety of making the product. And then the other piece, which is the mission assurance, is to ensure that as the design engineers laid out the design of the motor and how it's supposed to be put together, we then go out on the floor and do the testing and the assurance and look at the data and how it's being built to assure that we are meeting what we call as designed, that our as-built motor is as designed. And basically a liaison kind of between the design engineers who have put that together and then the operators who are building it and the process engineers to ensure that the process engineers and operators are building as designed per the design engineering group.
Now, I don't know if you have like a ready-made answer for this, but when it comes to QM1, and of course you have the design of what you want the booster to be like.
That's right.
How close is it to that design?
So it varies with every rocket. That's actually a really great question. So my entire group, I mentioned this, is as designed versus as built. And sometimes it's out of our control. For example, you can have an obsolescence issue. For example, we have a vendor that either maybe doesn't make a product any longer. And so as designed, we had maybe called out a certain adhesive, but now we have a different adhesive because the manufacturer no longer makes it. So we'll go through and make sure that it is still a one-to-one interchangeable between what was as designed. But in a motor like this, you have, let's say, you'll probably have several waivers that go along with it. And waivers are waivers from as designed. And we'll go through and make sure those are categorized and understood. And with this motor, it's a pretty clean motor, so we're excited to test it.
Now, this motor actually is not brand spanking new all the way around, is it?
It is not. We are reusing some of the hardware, and actually we're really proud of that. That's allowed for, one, to expedite the process of building it, and then two, saves on cost, which helps all of us.
Which is, of course, passed along to the customer, in this
Absolutely.
case, NASA.
Yeah.
So that's a very good thing. Now, if I remember correctly, there's only like 3 elements that are brand new for this one.
That's right. So we have.
And they're minor.
They are.
I mean, in terms
but
of
some things we have to have new every time, right? But you're right. We have only 3. We have 3 brand new things we'll be testing specifically, and that's the new avionics package we have on this motor. We have an improved safety flight termination system, and we have a new insulation, which we're also testing.
Now, I've heard a lot of rumblings about the avionics, and I don't know how much you can talk to that, but I know that it's new on QM1. Can you give us some of the broad subject, the broad details in terms of what it is? What's
so the avionics are the piece of the vehicle that steer it, if you will,
right,
and get it to the location. So it will be both tracking its performance as well as steering using the TVC and so forth to get it to the trajectory and to the orbits that we're in flight, of course, not today, but we'll be testing that out.
Well, I mean, with that, I know that you got a lot of stuff to do, and we got a lot of guests that are coming on, and I'm waiting, and I think, yes, our next guest is here, and it's actually, now, how do you work around so many astronauts and just keep your cool? I mean, what is that like? You work with at least 3 that I'm aware of.
It's easy to be starstruck, isn't it?
Yeah, I mean, I'd be like, can you sign this for me?
You know, they are just humble, down-to-earth folks, and they want to do a good job. And, you know, sometimes, I hate to admit it, sometimes they even forget, but very rarely, because you've worked with them all the time, every day.
And it slips your mind.
It does.
This guy's been to orbit 4 times.
That's right. Impressive. But that's one of the benefits of working here, I think, a side benefit.
Let me ask you this from a personal perspective. Does working around them help you focus more because you're realizing that people like the guys you're working with
Absolutely.
are going to be relying on your product?
Absolutely. It is a great reminder, and they always have real tangible stories to bring it back to home. Mm-hmm. And drive a message home in a real uplifting way and motivational way. So it's, a neat benefit to working here.
Well, we know that you're going to have a busy day. And Sarah, you've been great. Thank you so much. Yeah.
Oh, yeah. And if you don't mind real quick, hi, Mom.
Hi, Mom. Where's Mom at?
Mom's in Virginia.
Hi, Mom in Virginia. Are you near Wallops?
No, Southwest, Galax, Virginia.
Galax, Virginia. Hi, Mom. Your Sarah did great. I mean, she's awesome. She opened the show. That's how awesome she was. So, with that, we're gonna go to Shawnee. I'm gonna have you toss to a video pack. Go into some stills. You want me to keep on keeping on? You want to keep on keeping on? I should keep on keeping on. Well, with that, folks, we're gonna let Sarah get disentangled from the gear that we got on. She's not like Howard Cosell. She's got some other stuff to do today, but we're gonna let her get unblinged up. And again, Sarah, thank you so much.
You bet. Thank you.
Awesome. Spaceflight Insider fans, well, I'm back. We're very fortunate that right after Sarah Hiza, she set up the great interview that we have right now. And Brian, I think I've interviewed you at least once before. Is that correct?
At least once.
Brian Duffy, folks, Space Shuttle Astronaut and Commander on
72 and 92.
This is the man next to the other guy. Brian was very good enough to join us here in EFT1 for our live coverage of that. And we were very fortunate to have him back today. Now, Brian, QM1 is 4 of 5. Can you tell us a little bit about the of having all these tests in place?
Sure.
Why, you know, tell me a bit about the temperature story. One's cold, one's hot. What's going on with that? Why is that taking place?
Sure. So this is QM1, right?
Right.
Qual Motor 1. So why is it different than the DMs, or the developmental motors that we fired? The developmental motors are just what they say. We try to develop the final system, and we incrementally make changes and improvements, and then we test them to see how they did. And then if we want to tweak them to make them even better, we do that. So we've done that 3 times. We did it with a a cold case, a hot case, and an ambient case, right? And the reason we do all of those different cases is we want to verify the ballistics, the performance of the rocket motor within boundaries of where we expect to
tolerances.
operate. Yeah. So we really never expect to see they call it the PMBT, the propellant mean bulk temperature. In other words, the average temperature of the
PMBT.
PMBT.
Yeah,
okay.
I'm sticking with that.
We never expect to see that greater than 90 degrees. We're not gonna. It'll never get heat soaked so much that no matter where we're launching from. So that's the upper limit.
And so the cold one is at 40.
I don't know. I forget the number.
I think it's. But now, is that the same thing? Where if the hot is, you don't expect it to be any hotter. The cold, you don't expect it to be any colder.
We won't. We won't launch with it below that. Yeah, and back in the shuttle program, we had PMBT limits on there, and I launched on some pretty cold days. In fact, but the rocket motor was fine, because the mass of the propellant takes a long time to soak it to a temperature.
Oh, okay. So does that make the difficulty in testing with these temperatures? Is it hard to do, or can you tell us a bit about that? How do you guys raise and lower the temperature?
Yeah, so there's a building that covers the rocket. We had heaters in there, and they've been heating it for days.
Sean, if you're possible, we have some images of that building. We were the only media outlet out there, along with NASA, when they rolled it back. Okay, we're going to have that for you in a little later, folks. We actually have some images of the building that Brian's talking to. I'm sorry.
Okay, yeah. So we use that building to cover it, and then we heat it up, and so we've been heating it for days. I'm not sure exactly how many days, but it's been cooking for a while to get it up to.
It's been cooking for a
while.
Yeah. Now,
kind of like a turkey, right?
How do you heat it? Do you have heaters in the building?
Heaters, yes.
Yeah, you just leave the heaters on.
Right.
Right about now, I don't think I would mind. It's 90 degrees in there, right?
It is.
I think if it weren't for the fact there's going to be activating the rocket, I don't know that I would mind. Now, my next question is this. You flew on shuttle.
Right.
And I think I asked you this question at EFT1, actually. You got two of these, and I know they're like 20% more powerful than the 4 segments that were on shuttle.
A little more than that, yep.
So how much more does that relate into kick of the pants feeling?
So the initial kick, it won't be, I don't think, any different. I've seen some pressure traces of it, and it has to do with the way that the pressure builds up in the motor. So it's going to build up at about the same rate as it did before. It's just going to be able to burn longer and produce more thrust in the process. So just a little over 20%.
It'll be similar. Now that's probably because the SLS itself is going to be larger, and therefore the mass to weight ratio of lifting it up is going to be displaced by the weight of the rocket. Is that accurate or is that inaccurate?
Say it again, just so make sure I understand.
The core stage of the SLS booster is larger than heavier than shuttle.
It is. Yeah.
So those boosters on the side need to, of course, be more powerful to compensate. True. So is that a good way to relate the difference?
Yeah, and I believe that the liftoff Gs will be comparable to what they were in the shuttle program. And so you got more powerful rockets and a heavier vehicle.
And they require more heavy boosters.
Right.
That makes perfect sense. Yeah. Well, like shuttle, there's going to have a spacecraft on top. Orion, it's already flown one mission, EFT1, which we were both there for.
Fabulous mission, yeah.
With that, came back and they analyzed the data, and I'm making sure that all of our guests are on time. We got Todd May, who's going to be on here in a couple minutes. Yeah. NASA went back and they had Orion, and they said, okay, we don't need this much mass here. We don't need this much metal here. So they trimmed it back to save mass's life. It's very critical.
Correct.
So from what I understand, from what I've learned yesterday, is that you guys are kind of doing the same thing during this test stage. We don't need this much insulation, or we actually need more here. Talk a bit about that.
Yeah, so one of the changes, right? And so then in the course of the 3 developments, we were trying different things, and that included thinner insulation made of a different material, so it's lighter, which is great because it allows us, if you have thinner insulation, you can put more propellant in. You get more thrust, you get more performance for the rocket, so you can carry a bigger payload. So all of the things we're doing is to try to increase the efficiency of the rocket so that we can carry more.
So how would you say, because there was talking a little bit of history here, we went back, we were doing Constellation with Ares 5, and then it changed, and now it's SLS. How much of a disruption was there with the cancellation of the program, or was there any disruption? You just guys kept...
Yeah, I think it cost us some time, just because, when the people didn't have the ability to authorize work until the new program was established. So until SLS was established, there was a gap there where not a lot of progress was made. Now they were still doing things.
Did you guys kind of make up that time loss, recovering from that?
We think with that we're doing just fine on our schedule right now to meet the SLS schedules. So there's no need for us to rush. As long as we stick to our schedule, we're okay. We're doing well.
Well, Brian, again, I can't thank you enough for coming on. You got to. I hate to say it. I feel bad for we got a really special guest for you coming up next. We kind of want to make sure that he doesn't. Is he good with his time? Because could we maybe have a couple more minutes before we have him come on? We have a couple more minutes before he can come on. You're good? Okay, he's nodding yes down there. Okay. Because I don't want to rush Brian off. Brian, you're always great for an interview. So today, it's going to activate for 2 minutes. Walk us through the test. What are we seeing, and why? What should we pay attention to?
What should we pay attention to? What you're seeing, the rocket out there that you're looking at looks a lot like other ones that we've seen, but it's very different. Mm-hmm. The technology is the same, the idea is the same, but the design of the booster has been changed quite a bit.
The devil's in the details. Is that a good way of saying it?
Exactly right. Yeah, and so essentially we've changed nearly everything. The rocket, some of it's very minor tweaks, and some of it's pretty major. Some of the changes,
different skirt, avionics, the insulation,
nozzle, propellant formulation. Slightly. That's one of the smaller ones.
I was talking to Rommel during EFT1, and of course we would be remiss if we didn't touch on all the topics, because this is one of the events that happened with QM1. Is you guys were supposed to launch or test this last year, and you discovered voids.
Yeah, it was in the insulation and the layup. And again, we're using different materials than we did in the shuttle program. Some of the materials weren't environmentally friendly.
Asbestos is not environmentally friendly.
Well, and that wasn't alone. There were other things. So we had to make some materials changes, and those materials didn't exactly work the way we thought they were going to. Mm-hmm. And so it popped up a couple of little problems for us to deal with, but we've done very well with it. It did cost us some time. Our time delays, though, is not affecting the program schedule. So we had that margin in our schedule to be able to handle it.
So it all worked out in the end. Well, Brian, we at Spaceflight Inside want to wish you guys the best of luck in today's test. We're very excited. It's very cool that we have you right over our shoulder.
It is.
But with that, we want to get the special guest up. Sean, I'm going to make this one. I think no one really knows who this person is just yet. So if you could throw to a video or a still, we'll have his lower thirds come up, and when we have him on. Thank you. Let me know when we're clear, and we'll swap out. All right, Spaceflight Insider fans, we're back, and as promised, we have a very special guest. This is Todd May, the NASA Program Manager for the Space Launch System. Todd, welcome to SFI Live.
Good morning, Jason. How are you doing?
Cold hands.
It gets cold after. It's like a wet cold, isn't it?
I'm from Florida. This is insane. I don't know how you guys can do this.
We had some media ops up at the booster at 5 a.m. this morning. It was really cold then.
Yeah, I see. That's when you have photographers. You say, "Yeah, I gotta do a report," or you got that right.
Exactly.
Did disposition of responsibilities. They don't mind. They love taking pictures, and we're very lucky. A couple days ago, we had to go out, got to see the rocket, and they rolled the building back, and it was gorgeous out, blue skies, and we're getting all this great information about QM1, Todd. People are telling, okay, well, it's going to be doing this. We're going to be testing 8 avionics, the skirt, the nozzle, and I was here for DM2, and so there's DM1, DM2, DM3, QM1, and then next year should be QM2.
Right.
What I would like you to do is tell our viewers a bit what happens after today, up until first flight.
Okay. Well, first of all, we got a lot going on in the Space Launch System program right now. There are literally projects all over the country happening simultaneously. We actually have over 600 contracts in 42 states.
Right.
Just kind of working through the vehicle. The engines, the liquid engines, are already built. They're down at Stennis, and we're flying them on a new rocket. And so there's some changes in the inlet pressures and the inlet temperatures and the environments they're going to see. We've actually taken and designed a new controller. The old SSME engines had 30-year-old controllers. We're now
what are controllers? Give our viewers a little bit idea.
So the controller is basically the computer that checks on every aspect of the engine as you're flying, continuously updates the performance and the speeds of the turbines and the flow rates and valves and things like that. It's like a health monitoring system. It's also a control system for the engine. So we updated that based on the work we did on the J2X. So there's a brand new controller.
Okay.
And so we really wanted to get into test this year. And in January, we ran our first engine test, a full 500 seconds with the new controller, which proves that the controller now works well with it.
Okay.
Through the rest of the year, we'll do 7 tests on that engine. Down at Michoud, when we talk about the core, we completed CDR last year, so we're in the build phase.
Right.
We have over 40,000 square feet. I think you went down to Michoud a while back to see the VWC.
When they unveiled that, and it's folks, when you think of a machine, and I think most people that are watching the show think, well, they got a washing machine, or they got a sewing machine, or and you think of that scale. Now imagine you're going into this. Words fail me, but it's basically the machine is the size of a small building.
Right. So what you saw was the VWC. That makes one cylinder section of the rocket. What we just christened last September was the Vertical Assembly Center, which is where we take those segments and we stack them up. It's even bigger. It's 217 feet tall.
Okay, it's bigger than the one that I saw?
Yes.
Because we had our Marshall correspondent, Scott Johnson. He was there for that, and I got some shots, and I mean, it's just the scale is talk a bit about
So it's large. It's 217 feet tall, and that height is just the height of the hydrogen tank, basically.
Right.
So you've still got to put an oxygen tank on that. Then that's just the end of the core stage. Then you've got to put the LVSA, the ICPS, and then the Orion on top of that. So it's the scale is pretty overwhelming sometimes. So we've got about 40,000 square feet of hardware down there, including the first 2 cylinder sections of the flight rocket. All the flight rings, made a lot of progress there. The avionics is now being loaded into what we call the Systems Integration Lab. We've got a ring that's 27.5 feet diameter, representing the diameter of the core. All the boxes are going in there, and we've got flight software version 10 up and running in there now. When the booster guys finished all their avionics testing, all that ship set got sent to Marshall, and so now that's being integrated into the SIL. The ICPS is the structural test article is being built. All the tanks are done now. The LVSA, which is the Launch Vehicle Stage Adapter, also being built now. There's 2 new structural test article stands, one of which is over 200 feet tall, to test the tanks once they come out of Michoud, structurally take them through their rigor. That's all happening this year. The big event in terms of the entire rocket is we're doing critical design review of the rocket this summer. And so that basically says the rocket is finished, we're done designing, here's a small punch list of items to finish that, and now we get into manufacturing verification.
1 minute, please. Okay. Just making sure, folks, every once in a while we get little words in from our producers, and just make sure that we're still, we're in the high desert here in Utah, so sometimes the signal cops out on us, and we just want to make sure that we're still transmitting, but we're all doing good. So, Todd, again, what are the milestones we're going to be seeing past QM1?
So Past QM1, so that's all happening this year.
Right.
As we head into next year, we'll start taking the tanks that we have build up the flight tanks. We'll start putting thermal protection around those. We'll start putting those together, putting the avionics in. As we head into late 16, early 17, we finish out the core. The core then goes to Stennis right up the road on a barge. We actually took the old space shuttle barge, the Pegasus. Yeah. We cut it in half, stretched it 65 feet. It's now longer than a football field. That's what it's going to take to put the core in. We take it up to Stennis, put it up on top of the old B-2 stand, and we'll do a full stage test. And then that same stage gets sent down to the Cape for launch.
Now, you got to do fit checks to make sure that, because it would be kind of embarrassing. There's a great little interjection we put here. We went to the ASOC down at Canaveral, and there's all these great, beautiful models that you guys have. Yeah. Well, the one for the Atlas 551 was bigger than the ceiling, and they didn't realize that when they got the model, so they had to make this
cut the end off.
Yeah, no, they actually took one of the tiles out of the top of the ceiling and have this there's this big hole in the rockets going up through the ceiling. So obviously you guys plan well in advance for
Sure. So we have to model a lot of things. In some cases, like when we flew the ICPS or the MSA on the EFT-1.
Yeah.
Okay. We actually took a Delta 4 Delta 4 upper stage, which is the same upper stage as the ICPS. We got a mock-up of that. We brought it to our MSA early, took it, set it down on top to make sure all the bolt holes lined up. Now, we'll do those kind of things.
We've actually seen some folks that were like critical of these models. Oh, that doesn't even look very complicated, or it looks kind of silly. And for those that aren't there and don't understand that like you were saying, the scale of these things, you have to have this stuff.
Yeah, it's a lot different than it used to be. The model, a lot of things now we actually have completely modeled before we ever build it in 3D, and so the models is you can start working through even with ergonomics of what it takes to put together the pieces and things like that. So we use all of those state-of-the-art tools today. The models now are integrated with the drawings. They're integrated with the thermal models, the environment models, and things like that. And so all the models kind of work off the same set of CADs.
Now let's talk. I think we got you for we got you about another minute. Let's talk 17 and then EM1. 2017 and EM1 real quick.
Okay.
Just basically break down what milestones we're going to be seeing there, and then the first flight of SLS.
Okay, so we're now targeting 2018 for the launch. So during the year of 2017, all the hardware starts showing up at the Cape, and so at that point, when the hardware on there, we hand it over to Mike Bolger and the Ground Systems Group, and they actually take the pieces of the booster and stack them in the VAB. They take the core and they put it down in the middle. And then they have the Orion stack and they stick that on top. And then that whole entire last 6 months is their job. We hand it all over to them, and it's their job to get it off the pad and clear the tower.
And then they're basically, right now, what you're waiting on is to get the stuff down to the Cape, make sure it all fits together, it works as advertised. You're going to check it out, test it out. And then 2018, first flight of SLS.
Ready to go.
You're still going with that date, right?
Yeah, sure.
Well, we got another great guest that's joined us, and he's in our quote-unquote green room, which is this great tent we got behind us right now. But we don't want to keep him waiting. Another special guest there, Sean, up in Canada, if you could do us a favor and give us a cutout. So, Todd, we can get our bling back from you, and you can get on and see the rest of your day. Thanks for coming on Space Flight Insider Live.
Appreciate it. Thanks for the interview.
All right, Spaceflight Insider fans. Well, the hits just keep on coming. Right now, we are joined by one Senator Rob Bishop of Utah. Congressman.
Yeah, you just insulted me, right?
Well, you know what? Considering how things have been going, I can see how that would. We don't want to ever insult you. But Congressman, welcome to SFI Live.
Hey,
thanks for coming on. This has to be really exciting. So, I mean, for Congressman, this is your district. You're looking at what your neck of the woods can do. But I got to ask this question. When folks think of Utah, do they think that this kind of stuff is happening here? Is this something that is ingrained with the populace, or is this something that's kind of surprising when they see stuff like today?
That's a good question. I don't really know how most people think of it, but for those of us who are around here, I mean, this has been kind of like the bread and butter of my community. So I live here. I live in Brigham City. These tests are wonderful tests. When I was teaching school, I could tell when the tests were going on because the building would rattle. It says something about the construction of the school.
Right.
Whenever these tests were going on. This is very important. And now back in Congress, I realize why Orbital ATK is so significant. This is not just about space. It's also about national security. It's about defense. The same workforce that will produce this test produces what we need for the defense of this country. The same rocket motors are essential. So having a workforce that's there and viable has significance just beyond my district and beyond the state of Utah.
So let me ask you this. Do you think that having, like you said, Orbital ATK deals a lot with defense systems. Is this kind of like the icing on the cake? Because not only do they make sure that we're safe as a nation, but they're also enabling our capabilities for future deep space exploration efforts. Is that an accurate assessment of how it looks? It's just the hits keep on coming, like I said earlier.
And I don't know if you can really identify which is more important than the other. I think they go together.
Really?
If we have an active space exploration, you're developing the same technologies and the same infrastructure needs that will defend this country in our missile system. So it's the same workforce, the same product, the same solid rocket motors that are essential for everything. So I think it's very important. The fact that we are now, I think, putting more emphasis on space exploration is great. And the workforce becomes significant. I mean, look, they had some significant technical issues with this flight. They were able to solve them. So I'm hoping, praying that everything goes well with this, because that kind of ingenuity, that kind of creativity on the part of the workforce that's here means in other areas they'll find that same creativity, that same workforce, they'll move us forward again. So I think everything is overrelated. Our national security is not just defense, it's also the future in space.
Let me ask you this. Now, you said that when you were a teacher, you could tell when the launches or the tests were going on. Have you been out here before for other prior tests?
Yes, a couple of them.
It's fun, isn't it?
It is cool. and you don't realize how far away it is and how loud it is and how big it is. And fortunately, like I'm an old history teacher, so I don't understand the technology at all. What they gain out of these tests is significant. I'll just take their word for it. All I know is it works and it helps and it moves us forward.
Now, you said that were your teacher, did you teach history?
Yeah.
So what do you say? What do you think it says about Utah that you guys are building the machines that are going to make history? This is going to be the craft that does that enables us to go to destinations we've never been before.
It is cool. Every technological advance, when we came up with the canal system, and then you came up with the trains, and that technological jump was a lot of people taking risks, a lot of people doing dangerous things. Then we started going into space, a lot of people taking risks, doing dangerous things. Deep space exploration, it's the same mindset, it's the same human capacity that's essential, regardless of what it is. It just means as we go forward in the future, we got the right kinds of people that can make a difference. And that's why I'm so proud of the workforce that's out here and what they've done. I'm going to be proud of this test.
So where are you going to watch the test from? Right here, right back there?
Yeah, right at the staging area here.
You've been these before, and I think that the congressman can agree with me. I've covered 60-plus missions, including shuttle. I've seen them as close as a mile and a half away. I've never tasted rocket fuel before. I mean, that's how close that he and I are at right now. I mean, literally, correct? You get that taste in your mouth.
Yeah, but it's still a long way. I wouldn't want to hike up to that thing.
No.
It puts out a kick. I'm glad there's a distance here. is if as you go back, the road from here back into Brigham City is going to be lined with cars and people who are just sitting out there watching the flumes go out. And
it's just like down at the Cape, isn't it?
It is. Yes.
It's just like at the Cape. The people line the roads to see these launches. And there's also something else. I got this today from my friends, and I'm going to put this up to the camera real quick. And this is from DM2. And what this is this is some of that Utah sand up there. It was turned to glass by the rocket engine firing. And so, I mean, the power that's about to be unleashed. Congressman, let me have you close with this. As not just a U.S. citizen, but as a congressman, and you're working towards the betterment of our country. What does tests like this do for you personally? What goes through your mind?
I get excited again, realizing that I think there was kind of a blip in our commitment to space exploration. I see us over that, and I see us going forward again. I think the Orion has proven its value so far. These boosters are proving their value so far, and there's a new commitment to excellence. And that says something about the spirit of America that is, to me, just great. And that's what I'm excited about.
Well, Congressman, from all our viewers, we have a small request of you. Keep supporting space. We love this stuff. I mean, this is our bread and butter. This is in our veins. This kind of stuff inspires us, not just as fans or as I just say as fans, but as a nation. It gives us something, a beacon on the horizon to aim towards. And again, thank you for coming on Spaceflight Insider Live.
It's great, and we'll see what kind of spin-offs we get from this. Something better than Velcro will come from this.
You better than Velcro and better than Tang. Did you ever have Tang?
Yes.
Oh, I remember that too. Scarred.
Not exciting, but yes.
Not lately. Yeah, me neither. Sean and we have that one video package that Orbital ATK has. It's pretty slick. It's very nicely produced. We use it in our video promo for this live show. If you could throw that up and let the congressman go about his day, well, again, thanks for joining us.
Thank you. Good to be here.
First of all, tell everyone what booster integration means. What does that entail?
So booster integration is essentially the process of bringing together all of the components and making sure they're all assembled, checked out, and ready to go.
And of those many, what are the main components of the booster, though? We've heard about the aft skirt and the motor, of course.
Right, so we're essentially going from the nose cap down through the forward skirt into the motor elements, aft skirt, and then the exit cone.
So we're actually conditioning the motor today, and outside, for us anyway, it's a little bit overcast, a little bit chilly, not too bad though, but the motor is under almost tropical conditions.
It is. Now, this motor has to be qualified from 40 degrees Fahrenheit up to 90 degrees Fahrenheit. This is our hot motor test, so it's just over 90 degrees. And you might think that 90 degrees doesn't sound hot, but keep in mind there's 1.5 million pounds of propellant up there that we had to get up to an average temperature of 90 degrees.
And this is the kind of temperatures that it could experience as it launches from Florida, right?
Essentially, long-term exposure in Florida.
Of course, that's not including the many, many degrees higher that it will be when it actually launches at the business end of the nozzle.
Right, quite a bit warmer on the inside and coming out the exit plane.
Well, I imagine that you and your team have been working very long, very hard on this. What goes into the months of preparation for this test?
You have a lot, going on to the physical assembly and integration, a lot of instrumentation going on, a lot of checkout, a lot of data systems, just making sure that everything is really queued up.
So a lot of folks at home may not know that you were actually the former test chief engineer out here at Orbital ATK, so you've had a lot of experience on this test stand. Can you tell us about, let's see, some of the safety that you and your team would take into consideration before you have a test like this?
So, obviously there's been quite a bit of safety elements going on so far. They cleared the bay, lots of gates and lights and clearing, everything going on right now. The closest people are in the control bunker, which is actually underground, and then we're here at the closest that people are allowed to be above ground.
Those that we're allowed to view it from here, of course. Now, we mentioned that the team has been here since 3 o'clock this morning when they first rolled back the building, because the booster itself is actually tied down, right? So it can't go anywhere.
Right. The booster is not going anywhere. It's into the thrust block, which is going to react the 3.6 million pounds of thrust. It's tied down in several locations through the test stand. It's got a restraint system, and the crew's just been busy making sure that everything is all tidied up.
Yeah, and I know they've been there. What are some of the other things that they've been doing to prepare the site for this test?
So, obviously smoke and fire coming out the back end. We've got some concrete blocks on and lots of sand on the back end. We want to protect that concrete as much as possible so we don't basically sandblast the whole aft end of the bay.
Also hit the side of that mountain right there. Now, we want to mention that we've also got quite a few of our NASA social media enthusiasts here with us today, have been using the hashtag SLS Fired Up and hashtag Journey to Mars. So you've taken some time to speak with them. In fact, you spoke with them this morning. What were some of the questions they were asking you?
They were interested in, the procedures and the buy-off and what this qualification motor means to the overall verification. And, they're also pretty interested in, a female presence in engineering and in the aerospace industry.
Fantastic. Alicia, the booster integration with Orbital ATK, thanks so much for taking the time to talk with us today. So when it comes to, of course, igniting this booster, it's a bit more complicated than just lighting a match and running for the cover.
All right, Spaceflight Insider fans, we're back. As you can see, NASA's television feed has begun for today's test fire of the QM1 motor, and I have done something really sneaky. I went out and I grabbed an Orbital ATK person, and I said, come here and sit down and talk to me. Megan, welcome to Spaceflight Insider Live.
Thank you.
Now, what do you do with Orbital ATK?
I work in configuration management, which sounds fancy. Basically, we manage all of the requirements coming in from We look at all the design requirements. We make sure that all of the paperwork that gets created gets all of the requirements implemented. Get that feedback back to NASA that when we have a test like this, our configuration matches exactly what we expected. So all the hardware that we thought was going to go on this segment or this booster is on the booster. And building up to the test, we're checking all of that to make sure that our configuration meets all the requirements, and then we deal with a lot of the change paper. So when we finish this test and we discover some of the things that we'd like to modify or improve, we have a system to go through, and it's a process that we follow. And
I think you brought up something very good there, but I know that you actually did it. Is that when we think of rocket science, we think of these guys in the white coats and the big glasses and the crazy hairdos and they're cranking wrenches. But there's a lot of people behind the scenes that have to make sure all the things for safety mission assurance, like we talked with Sarah earlier on the show, and that we talked to Todd May, and there's all this stuff that you have to do, all these milestones you have to go through, and each milestone has countless check sheets.
Yes.
And stuff that you have to do to make sure that the customer, in this case NASA, has what it needs.
Yep.
So, talk a little bit about what it's like behind the scenes when you're designing and building one of these big boosters. What's that like?
There are lots of different disciplines of engineering that goes into this. This is a form of systems engineering, and so that really deals with, like I said, the requirements portion of it, and making sure that we can validate all of the things that the design engineers go and put on the rocket. And there's a lot of paperwork behind it, but it's really critical to make sure what we think we're testing is what we expected.
So this is like the icing on the cake for you, because you do all the behind the scenes. You're doing a lot of the behind the scenes work, and so this is the culmination of all your efforts, essentially.
Yeah, it's a big day.
Do you get to go down to Kennedy and watch the launches, or have you ever been down there and tried?
I travel down to Kennedy often, not for the launches. A different piece of my job. So the rest of the actually assembled out at Kennedy, and we have another piece of our company that's out there, and they're gearing up to build up the rest of the booster, and we're doing a lot of work for that, and heading out on Monday, actually.
Back to Kennedy.
Back to Kennedy.
What will you do this time?
Work with all the personnel out there. Again, we're working on making sure that we're managing our requirements, that all the hardware that we've got is ready to go when we start our build up, which is coming up here in the summer, and basically just making all of the buildings that have kind of been stagnant for the last few years are are up and running and that any new requirements for this program are going to be met and that we're ready to go.
Now, how long have you been doing this?
I've been with ATK or Orbital ATK for almost 8 years now.
And you like your job, don't you?
I do.
We're all jealous of you. You get to do what a lot of people only dream to. You get to build the machines that open up a new frontier for mankind.
It's pretty exciting stuff.
No pressure there, is there?
No.
Well, Meghan, we're going to let you get back to enjoying. I think, folks, we're hearing that everything is still good to go. There's like 13 minutes prior to launch. And what we'll do is we're going to go back to NASA TV here in about a minute for a few seconds while we swap out and let Meghan get about her day. Meghan, thank you for coming on Spaceflight Insider Live.
Thank you.
You're now famous, by the way. Do you want to say hi to your mom, by the way?
Hi, Mom. Hi, Sarah.
Shawnee, let us know when we're out.
Amount of energy that we're controlling here, and I always describe it as if you take a chair at the dinner table and lay it over on the floor on its back, and you laying on the floor looking up and imagine a giant hand reaching in under that chair and lurching you towards the ceiling, and then the push continues for 8.5 minutes, that same thrust in the back all the way to orbit. The key for a booster is to provide that thrust to be able to fly the vertical portion of the trajectory, lift all that weight to get us out of the atmosphere and turn the corner on our way to orbit.
And I think some of the things that folks are going to experience here anyway is you, of course, felt that all the way up. And for a good 2 minutes here, whereas at launch, for the folks watching on the ground, it's really only for a few seconds.
That's right. At the launch site, you'll feel the vibration waving towards you. But once that wave is passed, the vehicle is out of sight and you don't feel that anymore. You're going to feel it continuously here this morning.
We'll feel it and we'll definitely hear it because I understand that with overcast skies, it directs all the acoustics, keeps it pretty close to the ground.
That's likely.
Charlie Precourt, thanks very much for taking the time to see it. Let's hear a little bit more about QM1 and the SLS from one of Charlie's compatriots and fellow astronauts and a colleague here at Orbital ATK, Rominger, and from the SLS program, Todd May.
This upcoming test, the QM1 motor firing, is going to be a really big deal for us. These motors have 25% more energy than the motors we use to get the shuttle off the ground during the space shuttle days.
As a space shuttle astronaut, I flew the space shuttle 5 times. Every one of those was on the redesigned rocket motor that proved itself to be the most reliable rocket motor in the world. So this motor we're looking at here is called the qualification motor number 1. And it's actually the 4th motor in a series. We had 3 development motors. And on the development motors, they really are development, where you start out conservatively, you do a test firing, you see how well the insulators worked, how much thrust, what was the performance of the motor really, and then you start optimizing it.
So QM1 is the first of 2 tests that will be used to qualify the motors for flight. We're actually already building the pieces of the 2nd qualification motor flight. This is a really exciting time for all of us here. Coming off of Orion's first flight test in December, less than a month later, we have S-25 engines, which are the liquid engines that will power the rocket, have been tested at Stennis with a brand new state-of-the-art controller. The pieces of the rocket itself, the core, almost 30 feet in diameter, are all being manufactured at Michoud as we speak. There's a company called Conrad down in South Louisiana. They took our Pegasus barge, which is the barge we use to move the external tank around during the space shuttle days. They had to cut it in half and add 65 feet and stiffen it up to be able to handle the massive core that will come out near New Orleans to be shipped down to KSC. And then in a few months, we'll actually complete the critical design review of the Space Launch System. This is where we actually say we are now done designing and it's time to start putting all this hardware together and running it through its tests and verifying that it actually meets the requirements.
We're going to fly the SLS system in 2018, and between now and then we're going to fire this motor. Less than a year from now we'll fire the 2nd qualification motor, and then we'll start assembling that Space Launch System rocket in Florida in 2018. And the 2nd flight of that rocket motor will take astronauts further into space than we've ever been.
From there, we're now into the proving ground where we test the ability to be distant from Earth by days and weeks and getting ready for the long-term exposure to space that gets us ready for a Mars mission in the future. So they say the journey of 1,000 miles begins with the first step. In this case, our journey is millions of miles away to Mars, and we're starting to take these steps. The next step is going to be this QM motor firing, and we're really getting excited to see it.
We're about 8 minutes away from today's.
All right, Space. Wow, got a bit of echo going on there. We are back live, and we just got Meghan set on her way. She's pretty excited about the launch. The test is about to take place. We are under 10 minutes away from this morning's test fire of the QM1 booster, which will be used on NASA's Space Launch System. We've been pretty fortunate this morning to have a great lineup of guests: Todd May with SLS and Congressman Rob Bishop. Don't ever call him Senator. He's not wasn't too happy about that. He punched me in the stomach. I got a little winded, and I walked it off. It's all good. But all the guests have been fabulous, and everybody. There's one common theme here, and everybody's pretty excited about this. It's very cool what's going on. This market have been out here. It's the Utah high desert is gorgeous, and then there's rockets. And the folks at Orbital ATK and NASA have just been fabulous. They've taken really great care of us and make sure that we have all the assets that we need to put on this live webcast. And while I have a minute before the test begins, I want to thank some folks so possible. Of course, Orbital ATK put us up here. They got us up. They got the guests lined up, and we're rolling. Lockheed Martin, we'd like to thank them. We also want to thank the folks at Flexure Engineering. We know that we got a lot of space geeks that are out there. Real quick, next month, April 14th to the 17th, is the Lunar Surface Applications 5, the 5th annual workshop that they're going to be having in Cocoa Beach, Florida. So look up LSA Workshops. And if you like lunar landers, you like new space, you like commercial lunar landers, that's what they're all about, baby. You got to sign up, register now, go out there and make sure that you attend this event, because I'm going to be there. It's going to be awesome sauce. And I know that old middle-aged guys aren't supposed to say that, but it slipped out kind of. So we are slowly cranking down to the test fire today. It'll last for 2 minutes, full duration burn. What that means is essentially the booster is going to run for as long as it would if it was on an actual mission. And as you can see, it's right over my shoulder. When we get closer to the moment, I'll probably lean this way, or I'll lean that way, or I'll do something. And then we will close with some good folks that'll tell us a bit about what we saw and what the initial estimates were. We are now 6 minutes away from the test firing. When we get, I'm hearing two things at once, folks, so I try to focus through, make sure everything's going good. It's a little different than a rocket launch because you're always waiting for that one thing not to work, and they're saying, hey, we're encountering this, let's push it back further in the launch window, or weather's just gone red, and there ain't none of that. They're going to go, hey, there's the big red button, and then it's going to activate. It's going to run for 2 minutes, and when you're at an Atlas or a Falcon or a Delta IV launch, you get, maybe in some cases you get to feel the rocket, or because it'll actually start thumping your chest a little bit. Of course, the light gets you because it looks like you're looking into a blowtorch. The sound is incredibly loud. I mean, it sets car alarms off. It rattles windows for miles and miles around in Cape Canaveral and Wallops. And then you come here, and they really show you just what is actually going on, because you're not that far. I think you're less than a mile away. I would try to get the actual, and we are 5 minutes away from the test firing. We'll try to get you the actual distance, but you actually can taste the burnt rocket propellant. You actually can taste it, and you feel it, the heat. And I can't wait for this thing to activate, because it is, for a Florida boy, it's cold here. It's cold. So I'm hoping they crank this sucker up, and maybe it'll jack it up by about 5 degrees. Right now, I want some climate change. I want it to change warmer. But it has been very fun this morning. The folks have been great. The NASA social folks are out and about, and we've got a ginormous inflatable rocket that is over to our right. And with that, Sean, it looks like we have a. So if you want to throw to NASA TV, we're going to get him set up. That is awesomeness. So, folks, we're going to take a brief pause, and we're going to have a special guest while we are here. And with that, we're going out. All right, folks. Well, I'm joined by Orbital ATK, Stan Graves. Orbital wanted to make sure that they had someone who could see it with you. 3 minutes. We are 3 minutes out from the test firing of the QM1 motor. And Stan, tell us a bit about your responsibility in terms of what we're going to be seeing here in just a couple minutes from now.
Well, I'm the head of science and engineering for Orbital ATK. The engineers that design, by the way, I am a rocket scientist.
You are a rocket scientist?
I'm a rocket scientist.
Cool.
So, it really is rocket science. So we're going to see this booster go off in a few minutes, and it's going to reach maximum thrust in just a few seconds. And so all the folks that do the structures and ballistics and stuff all work for me.
The numbers on this thing are phenomenal. How many pounds roughly of propellant are there?
There's a little over 1 million pounds of propellant.
And it burns.
It'll burn 1 million pounds in just over 2 minutes.
That's insane.
So the motor weighs just over 1.1 million pounds, and when it's all done, it'll weigh about 100,000 pounds.
That is.
How about that?
I mean, we're about 2 minutes out, and so at this point, I think, I don't know. We kind of got Stan at the last minute. I'm like trying to focus on the launch. We're going to launch it. We've covered some 60 launches out at the Cape, and this is very different from the Cape. What you're doing here is actually leading to what we covered down there. So how involved are you in from where we are now, which is point A, to point B?
Well, of course, we're going to go from the ground test to test this thing all well. By the way, I've attended about 50 shuttle launches in my day, and I used to sit in the council and give the go for launch. So sitting in the building, you don't hear anything in the LCC.
Yeah.
Sitting in the building, you don't get to feel this thing. For 2 minutes, we're going to feel this thing shake and rattle and roll.
I was just saying that. You not only
power,
feel it, you can taste the rocket fuel.
You can. Well, you don't know about taste.
Well, I mean, I don't know, but you can smell it at least. You can definitely smell it.
This thing's going to shake and rattle you pretty good. It's going to make a lot of noise.
What part of the noise it is? With that, guys, we are going to basically let Stan and myself in. We're hearing the sirens.
1 minute.
Stan, do you want to go somewhere else real quick and watch the launch, or you want to just turn around and watch it here?
I could turn around and watch it here.
We want a clear field of view, but we're going to kind of canny around a little bit here. And seconds away from the test of QM1, folks, and it looks like there are sirens going off. It's cold. Now, Stan, we were saying earlier that the low cloud layer actually means it's going to be a bit louder, right?
It should be a good show for us. It'll be really loud. It takes after you see the flash of light, we're about a mile away, so it takes a few seconds for the sound to get here.
I'm going to get out of screen all the way, Sean. Five seconds. Look at that. There it is, folks. QM1 is live. We want to thank everyone for watching this today because this is just phenomenal. You do not know the power that is being unleashed right now. It is incredibly loud. There is a massive plume that is just shooting up into the sky right now, and the flames are just intensely, intensely bright. You can feel the thump. It is just incredibly powerful, folks. It looks like a bomb has gone off. There's so much dust and ejecta in the sky right now. Oh my God, that is incredible. I got to sound like this one guy they had on the show, this silly little guy. He goes, oh my God, it's going to be loud. Well, oh my God, it is loud. You got guys in front of us that are taking selfies over here. There are a lot of selfies going on right now, folks. Stan, how high does the plume, does it kick up, would you guess that is?
Probably up a couple thousand feet by now.
Oh, man. So what Stan is telling us is the plume that's kicked off from the QM1 rocket motor is actually a couple thousand feet into the sky. Are they actually hearing me, Sean? Great. Glad to hear that, folks, because I mean, I wish anyone that is in love with spaceflight as we are, Spaceflight Insider, could have the opportunity to see one of these, because it really lets you know just how much time, energy, and just investment people have to put in to make things like this happen. And then when you look at the payoff, well, Stan, why don't you talk about that?
Hey!
See, that's what's...
Yeah.
I think that about says
That
it all.
gets the heart pumping, doesn't that, a little bit?
Congratulations.
Thank you.
Oh, that was just gorgeous, folks. And we're so very happy that we could be able to bring that to you live. It was amazing. Right now, there's still some flames visible coming out of the back of the QM1 motor, and the smoke, if you will, is switching from a brown to a white. The brown is basically the stuff that's mixed in with the ash and the particulates that's blown up off the desert floor. And the black is actually, I guess, residual fuel that's being burned up right now?
Well, not fuel. There's rubber insulations and nozzle insulation that are continued to burn. We spray a carbon dioxide coolant in there to cool the motor and chill the motor so that we can reuse all the metal parts. But there's still some materials inside the motor that are hot and burning.
And so now, basically, this is a no man's land up there for a little while.
I've got to go.
You got to go? Stan,
go.
Thanks for coming on. That was amazing. Congratulations. Good job, sir. All right, folks. Well, I'm going to get situated here. Please don't laugh at me too loud. I'm going to also fix Stan's headsets while I'm talking to you, because we are real. We're not Gator Boys or Pawn Stars. We actually are live, and we try to keep it as real as possible. But that was pretty phenomenal, Sean. I mean, you just do not get. You get that from launches, but it's just this huge plume was just thrown up in the sky like that. And what's really cool is the flames coming out of it, the thrust, are messing with that plume cloud. So, you've seen exhaust come out of the back of your car. Well, imagine like some wind is blowing that hyper fast. I mean, the clouds are just really moving. I mean, they're really getting up there. And as Stan was telling us, it's more than likely that this plume was going up a few thousand feet into the sky, and you have incredibly bright flames. And right now, I'm going to reach back into my pocket. There's a whole lot of this right about now, and this is glass that was made from the TM2 test fire. Just so cool, very cool. Our last guest for today should be Gordie Russel. We actually interviewed Gordie for a special video feature that will only appear on Spaceflight Insider Live yesterday, and he's going to sit with us for a few minutes. And with that, then after that, we got to close down the show because there's going to be a press conference, and then there's going to be the we got to go pick up the cameras up there, because we actually set still and video cameras up there, which is the thing I'm stressing about right now. Because if it looks half as cool close up as it did from way back here, you guys are in for a treat. And you always should remember, if you want to be brought to where it happens, there's only one place to go, folks, because there's NASA TV. There's a NASA TV trailer light right there, and then there's us. There's maybe did ours? Oh, okay. We are hearing, and folks at NASA, we do love you. We wouldn't do this job if we didn't love what NASA does. But apparently, at the point of ignition, we are hearing that NASA stream may have ran into an issue, which meant that there was just us. Spaceflight Insider was live. I'm probably getting bad information. I don't know. I'm so excited right now, folks. You just don't know. It's been a cold morning. I'm slightly warmer now, but that was incredibly exciting. And, Shawnee, let's give it back to NASA TV to see what they're going to, because they're probably going to be showing some replays while we work to get. Okay. With that, I'm waiting on Mr. Russell to come join us, and he will be our last guest for today's live webcast. Now, you're probably saying, well, that's great. Now what? What are you guys going to do for us now? What can you do for me? Gordie! Gordie's here. Hang on, folks. All right, Spaceflight Insider fans, we'll close out today's live webcast coverage of the QM1 test fire in Promontory, Utah. I am joined by the man, the myth, the legend, Gordie Russel. Gordie, thank you for coming on Spaceflight Insider Live.
Thank you for having me.
What are you feeling like right now, man?
Yeah, I'm still shaking with excitement. This has just been an amazing day. This rocket booster didn't even leave the ground like a launch, and it was just so amazing to me. The power we felt for the whole 2 minutes of burn, I just can't get over it.
Can I ask you real quick? Now, I know you guys got to sift through mountains and mountains and mountains and mountains of data. How's it looking right now? Everything looks good from where we are, obviously.
From a visual, everything looks good. In the next hour, we'll have the initial thrust trace, so we know exactly how much power we had coming out of that booster. And from that, we'll be able to tell from a quick look that we're good to go.
Now, I know I got you in kind of a biased position because you're totally stoked right now. I mean, I can see you're like vibrating over there. You're so excited. What do you think this means for the future of manned spaceflight, deep space missions?
You know, this is the first time in 40 years that we've done a full qualification of a real program that's going to take us deep into space. And so this is our future. And I would look towards, the youth, 11 and 12-year-olds now, that you guys are going to be the guys riding this thing, and we're here building it for you. So
now, we saw that there were a lot of people actually viewing the launch. So, I mean, do you guys have any idea of how many people actually came in to watch this morning's launch test
firing?
Yeah.
We are expected just up here in the VIP viewing area, more than 800 people, close to 1,000. They were expecting, to have overflow parking lots on the main road just because of all the people and school buses and everybody that was coming just to view this 2-minute firing. So. Actually,
and I don't know if any of them are watching the show. We actually, I'll say this real quick, and I'll let Gordie let you give us some closing thoughts on today's test. One of the things, the common myth about our website is that the insider is us. We're the insider. No. We actually will take people's questions, thoughts, and requests if they're doable and bring them to the people. A lot of the questions we ask during the press conference come from our viewers. We want to bring them inside. So we had a couple of teachers. I don't have their names off the top of my head right now, and plus I probably couldn't remember it. I'm so excited. Anyway, I totally would have forgotten. But they post questions, say, hey, well, where can we view this from? And we did what I think any outlet should do, pass along the information to Orbital ATK, and I think they got them to come out there and see this launch. So, okay, Gordie, you got QM2 coming up.
QM2's coming. We'll be to a cold motor. This was conditioned hot. We're testing all the corners of the boxes to make sure that this vehicle is safe and reliable. I think we're heading that way. We're good to go.
Well, with that, I think we're going to close today's live webcast with just a simple congratulations.
Thank you.
That was beautiful. Great.
Hey, I can't wait to see the Earth rise from the surface of Mars. So.
Oh, I love that. That's awesome. Shawnee in Canada, what do you got for us? I think that you mentioned real quick, Gordie, about the students that you're working with. Well, when EFT won, we had astronaut Abby on our show. She actually was our co-host, and I get inspired by doing this. I think anyone that gets involved in this is, but she's so motivated and she's so dedicated. She's willing to contribute, just all of her time and her energies into be flying on the rocket that you're building. So, we want to give just a shout out for astronaut Abby. We know that you've been talking about us.
Hi, Abby.
We saw you. Hi, Abby. We love you, kid. You're doing great. What you saw back there is part of the equation that's going to get your boot prints on Mars. Also, guys, this is exciting. We got commercial companies are going to handle LEO from now on. But these guys, they're going to send you to Mars. They're going to send you to an asteroid, to moon. Go to school. Get your diplomas. Go get a good degree. Build our future. Make us proud, folks. He needs to retire one day. He can't work forever. You need more rocket science to replace this guy. Come on, help him out.
Stay excited, stay focused.
Yes, exactly.
But stay excited. Stay excited.
And with that, guys, Shawnee, do you have anything else for us in Canada? No. And with that, guys, it was awesome. Stay tuned tomorrow for Spaceflight Insider live coverage from the flight of MMS from Cape Canaveral. It'll be the flight of a United Launch Alliance 421 booster. I wish I could be there, but of course, I was busy. So with that, we're going to hand it off to the Canaveral team to continue coverage of spaceflight as it happens. And we're out.
Fire.
We have ignition of NASA's Space Launch System 5-segment solid rocket booster.